Example 3 says find area and perimeter of the rectangle. Go ahead and draw the rectangle that you see on the board on your own graph paper. If you need more graph paper, let me know. I got plenty. Does anybody need some graph paper? Good. Go ahead and copy this down. I got a rectangle, 12 inches long, 5 inches wide. Go ahead and copy that down. So no one should be looking at their computer screens right now. It's the same as looking at your phone. You might lose your stamps. So be respectful and take notes. All right, here we go. We got a rectangle. So a rectangle, according to our formulae table, is a second shape down. Let's find the area first. Mr. Rojas, can you give me the formula for area of a rectangle? Equals what? Hit it. Gracias. Look at this. Length times width. What is the length and the width? Well, the length is always longer side. Always remember length and long both start with L. Longer side is length. So in this case, here we go. Guzman, let me talk, please. Thanks. So notice look at these. These units are now, we know what these units mean. They're inches. They specified. So our final answer is not going to be units. It's going to be inches. Certain types of inches. So the length in this case is going to be 12 inches. The width is going to be 5 inches. Let's rock and roll. I want to say 60 if my coffee is kicked in. 60 what, though? Chickens, horses, or termites? One more time. Right. Remember, area is how many squares fit inside. So I'm going to say inches squared. And you can actually see all of them. If we had no life, we could just start naming. Look at it. There's 6, 7, 8, 9, 10, 11, 12, 13, 4. There's going to be 60 square inches in there. Square inches that fill up the rectangle. Hence, our area is 60 square inches. That little second power from yesterday, we were reminded, means a square inch. Nice. Let's find the perimeter now. Remember, a perimeter is like fencing around my garden? Add those sides up. Gonzalez, I'm talking. Thank you. Gonzalez, I'm talking. Gomez, hit it. What's perimeter? Nice. Look at normal inch is distance. 1 inch, 2, 3. Here's 12. Here's 5. Here's 12. Here's 5. That's going to be 34 normal inches, not square inches. Normal inches. That's the fencing that surrounds. Who? Have her call me first. Nice. Rocking and rolling. Simple. Example 4 now. Here we go. Questions on example 3. Excuse me. Here's example 4. Not 5, but 4. It's a 4-sided quadrilateral, which is actually redundant. It's a 4-sided figure. What kind of shape is this? Help. Trapezoid, definitely. And what makes a trapezoid is that you have two sides. Watch this. You have two sides that are parallel. In other words, if I extended this side forever and this side forever, they would never intersect. Think about like 2 streets that never intersect. Like in Pomona, what are 2 streets that never intersect, that go the same way, north and south or east and west? Think of 2 streets in Pomona. I'm thinking Holt and Mission. They go east and west. Give me another 2 streets. Extra stamp. Tana said they go north and south. Thank you. Gary, how about Gary and Mills? They both go north and south. That's what parallel lines. So if you have a 4-sided figure with one pair of parallel lines, you got a trapezoid. Look at these two. If I extended them, they would actually meet up here, like way up here. So that's a trapezoid. If you only have one pair of parallel lines, let's rock and roll. This is the one that has the funkiest formula, if I'm not mistaken. The funkiest formula. Look at how funky that formula is for the area. Area is 1/2. Look at this. B sub 1 is base 1. B sub 2 is base 2. In other words, this has two bases. And the two bases end up being the two sides that are parallel times the height. What color did I color that star yesterday? It was so important I chose the color red to color that star, and that star said what? Extra stamp. Hit it. Go ahead, Novato. What does perpendicular mean? What does perpendicular mean? Wait, what does perpendicular mean? No, that's perimeter. Nice. Perpendicular means what? It meets at what? How many degrees? 90. That's what look at. So watch this. If you ever want to find the height of any, whether it's a triangle, whether it's a parallelogram, whether it's a trapezoid, if it has a height in the formula, the height, the h, you always look for 90 degrees somewhere. You always look for 90 degrees. Look at this is the height then, because look, it touches this side at 90 degrees. So this is the height. This is one of the bases. Let me say it again. Watch this, Rivera. Look at the other formulas. What other formulas have height in it? Let me see. Triangle. Look at triangle on top. The triangle formula is, look at 1/2 base times height. Look, it's got height. This one, the trapezoid that we're dealing with right now has height. What's another one that has height? Can anyone see it? Which has height? Area formula. Any other shape out of those 5 on top? Help, please. What are the area formula that has a height in it? Thank you. Parallelogram. Look at the parallelogram. We're going to do that next on example 5. Watch. It has base times height. Look at height, height, height. How do you find the height of any shape? Well, you look for where there's a 90-degree angle somewhere. Here's 90 degrees. Look at 90 degrees. Here's your base. Then that means this is the height. So I'm going to replace h with 8. So let's rock and roll. Here we go. Here we go. I'll go red for now. Area then is 1/2. The first base I'll put is 11. The second base is 5. Remember that the two sides are parallel. Times the height is 8. Nice. Please excuse. Go ahead. It's b sub 2. That's different than b squared. So look how the 2 is underneath. And all that referring, it's like a placeholder for a side, one of these two sides. Good question. B sub 2, not b to the second power. This is b sub 2, b sub 1. All these are like placeholders. Kind of like when you're out in PE. I think Mr. Udabi has those numbers out on the blacktop. Do you guys stand on your number? I used to when I was in PE. But those numbers are just a placeholder for me or for you. So these b sub 1 and b sub 2 are just placeholders for this side and that side. That's all it means, the two bases. Placeholder. Let's rock and roll. I think in middle school you guys learned about PEMDAS. What does P stand for in PEMDAS? Thank you. Let's do parentheses. 1/2. 1/2. Thank you. Thank you, Guzman, for putting your phone away. 1/2 times 16, I want to say, is, well, we don't have to run away and cry to mama anymore because we already know fractions. We're actually practicing in this class fraction. We did a quizzes on fractions. A fraction times a whole number, what should I do? Thank you. Make this into fraction, in other words. Thank you. And now fraction times fraction. Let's see. You can't see from there. It's numerator times numerator, denominator times denominator. Nice. 1 times 16 is 16 on the numerator. 2 times 1 is 2 on the denominator. Nice. Let's simplify 16 halves, though. Help. Thank you. 6, to simplify a fraction, I think the last question on your quizzes today, that was one question on simplifying. Just take a number that fits into both the numerator and denominator. 2 does. 2 fits into 2 once. 2 fits into 16 8 times. So it's really 8 over 1, which is 8. So I just got to have 8 over 8. If my coffee kicked in, that's going to be 64. Chickens, horses, or termites, so. Thank you. Close. What kind of meters? Right, square meters. Now, what the heck is a square meter? Can someone tell me what a square meter would look like if I encountered one? Would it like chase after me? Would it bite me? What would it do to me? What would it look like if I looked square in the face of a square meter? What would it look like? But has anybody met a square meter? Guzman, give me the lights real quick. We're going to do one more example. I want to, Guzman, turn on the lights because I'm going to introduce you to a square meter. We're going to meet a square meter. Right now, the area we're saying of this trapezoid is 64 square meters. But my question is a lot more simpler. What's 1 square meter? What does that look like? Extra stamp. Hit it. One more time. What does that look like, though? Can you describe what it looks like? Is it purple? Does it have? No, Rojas has got it. Would you say something or no? It's a square? Give me more. Give me more. So wait. Well, what's this? I drew a square. But what would make? But look at squares. Look at. Is this a square meter? That's still a square. But look at that. The area there is a square. The area there is a square. Draw a face. Leave me alone. Forget square meters. Has anybody met a meter? What does a meter look like? Like a meter reader, like for meter in that sense is it times your parking. But the measurement of a meter, has anybody seen a measurement of a meter? Has anybody seen an inch? What an inch looks like? You guys are scaring me. You guys from planet Earth? Millimeter, that's millimeter. Novato, you've met one? All right, I'm going to introduce you to a meter. Carmona, I'll first introduce you to a meter, and then I'll introduce you to a square meter. They're different. Here's a meter. Say hi, class. Say hi, Mr. Meter. Yeah, I know. This is a meter. This is a meter stick. This is a meter long right here. This is 1 meter, but it's not a square meter. Let me introduce you to a square meter. Watch this. Watch this. No, what you're going to see is a square meter, but I want you to describe it. Look at. Right. The perimeter would be 4 meters. You're actually right. The perimeter would be 4 meters, but I want to know what a square meter is. You have just met a square meter. Look at you guys. On the board. Leave it alone. So, that is a square, and every side is 1 meter long. This whole thing is a square meter. You're looking at one. And what we're saying on this trapezoid is, look, 64 of those puppies fit in this trapezoid if it was life size. Can you imagine? Think of this trapezoid. If this was 11 meters long, it would be a gargantuan trapezoid. And we're saying 64 of those would fit perfectly inside the space. Right. Chill, Rojas. Here we go. So now you know. Here you go, Rivera. Here we go. Now we know what a square meter is. How about a square inch? What a square inch look? It looks something like this. Right. And the perimeter then would be 4 inches. The perimeter here, Nevada, let me talk, please. Excuse me. The perimeter here would be 4 meters. But that's 1 square meter you're looking at. Now, let's go on to example 6. We're only going to do the area for this one. Example 5, rather. Example 5 says, here we go. We're going to do a parallelogram now. Last example. Example 5. Let's find the area only. Going to draw that parallelogram. Go for it. Yeah, separate sheet. That's fine. Last example. Draw that parallelogram. Now, what makes a parallelogram a parallelogram? What makes a Carmona? Let me talk, please. Thank you. What makes a parallelogram as opposed to trapezoid? Look at, we have two sides that are parallel. Look at this. These are parallel, and so are these. Look at, these two are the same parallel. They'll go on forever without intersecting. These will go on forever without intersecting. That's what makes a parallelogram. Everything's parallel, in other words. Hence the name. One more time. Exactly. They went on forever. But on trapezoid, you only have one pair of parallel sides. The other two are not. So this is one probably, apart from the triangle, is probably the easiest formula for area. It's on your reference sheet, is base times height. Now, think of yesterday's red star. Base and height are always connected by what? 90 degrees. They're perpendicular. So look at the base and the height here. Height, base, 90 degrees. It gives it away. Let's rock and roll. Area then is going to be, the base is 5 1/4. We don't have to run away to mommy because we see a mixed number, because we know how to deal with this now. And then the height is 2 2/7. No teddy bears. We're okay. It's going to be all right. Oh, Gonzalez, thank you. Go ahead. I think so. Let me double check. I didn't memorize you. Give me a second here. Watch this. All right. I got a mixed number times a mixed number. I got to do something to this before I multiply. Rojas, you're on it. What do I do? Nice. I'm going to change the mixed number to a improper. Yes, 2/7. Watch this. I'm going to change both mixed numbers to impropers. Watch. 4 times 5 is 20. Then to add that numerator is 21 over the same denominator. Nice. Look at it. This is the same number, just in an improper fraction method form. How about here? 7 times 2 is 14, plus 2 more is 16/7. Rocking and rolling. Sure. Here we go. Denominator times whole number, then add the numerator. Boom. And same denominators all the time. Always the same denominators. Now we're multiplying fractions. Right over here. Multiplying. Numerator times numerator, denominator times denominator. We're in business. But before we do that, yeah, the thing is, 21 times 16, I'm going to have some gargantuan, nasty, big numerator. To prevent that, I can cross-cancel. In other words, I can simplify the numerator-denominator. Simplify. I can divide this and this by a common factor. In this case, what goes into 4 and 16? That's the same number. Bigger, though. 4. 4 goes into 4 once. 4 goes into 16 4 times. Seven goes into 7 once, and 7 goes into 21 3 times. So now the fraction is actually turned into something else. 3 over 1 times 4 over 1. You got to be kidding me. Thank you. 12 chickens, horses, termites. What kind? Thank you. A square foot. Have you guys ever met a square foot? Yeah. Now you have. There's actually some right here by Alvarez on the floor. These tiles are square feet. Square feet. You guys are high school. You guys are thinking high school. I forgot. Never mind. Area is 12. Watch this. Second power communicates squareness. Get that second power going. All right. Watch this now. Watch this.